In the last few years, the use of wearables have been increasing. So now the users like to have some sensor, the athletes, for example, to see their signals. So the problem is that those signals can be noisy if the user is doing a high activity level, for example, because the sensor movements. So that's why we thought that it will be useful to design or to find a measurement to see if that signal is accurately or not. There are many companies that are building wearables. There are many users that are using these wearables to measure the heart rate, for example, the movement with using accelerometers. So we thought that in this kind of application it would be interesting to see if the signal is good or not. We developed a quality index for the electrocardiogram signal that can be used in some applications where the user has some sensors on body to measure biological signals. And this measurement can detect if the signal is noisy or if the signal is clean, or if the user is doing a high activity level or a low activity level. This is how the modulation spectrum looks like for an electrocardiogram signal. The left side corresponds with a clean signal with 120 beats per minute. And the right side corresponds with a noisy signal with an SNR of 5 dB. In this representation we can see that the spectral components, we can differentiate the spectral components of the signal because the electrocardiogram is quasi-periodic, and we found a measurement doing this ratio between the energy outside the spectral components and the energy of the spectral components. And this was we called MSQI. This ratio is like an SNR ratio. And we found that this measurement is between 0 and 1.5. So, and there is a good discrimination between bad quality signals and good quality signals with a threshold of 0.5.